Good morning to one and all, and a warm greetings to all. Before starting any functions, let me welcome our honorable and respectable principal, Dr. Mohan G. Dr. Mohan Babu GK, Principal BMSIT, and our all the Dean of Academics, and also the HODs of various departments, and chief guest of the today functions, Pravinjith, and also the participants of the today's program. And before that, I would like to give introduction about my department. Civil department started in the year 2013 with an intake of 60. And the department is also committed to impart quality educations to meet the requirement of the industry and also the society. And department is always following the outcome-based educations in all the branches and even at the institute level. And we are offering a lot of many the skill-based training certification courses, industrial visits, and also the many kind of the project-based learning to impart the more skills which are needed by the industry. We have a team of 11 faculty members with 6 doctorates, and the department is every year is improving its quality of teaching and learning process, and also the placement also is also improving in the every year. In order to improve as you know, we are affiliated to the Visheshwaraya Technological University, and we have a lot of some constraints with respect to the curriculum is concerned, and also to obtain all the learning outcomes of the National Board of Accreditations. In this in these connections, so we are conducting many activities beyond the curriculums to meet the requirements of the industry in terms of skills and the knowledge. So to be in that connections, we are organizing these FDP also to impart to the even for the faculty development program, and also for the students fraternity. So the department here we have many resources are there. We have for this FDP. Now I request all the participants to make use of this the FDP fruitfully and effectively, and please have a discussions, interactions with the speakers, so that you can enhance the knowledge in the field of civil engineering. What are the current trends and practices which are being followed in the industries? So this is about our department. Now I will request the Anup or Dr. Anup Kumar G. Ebkote, the Assistant Professor of Civil Engineering, to brief about the FDP. Over to you.
Okay. Sorry for the glitches. We had some miscommunication or misconnection. Now the FDP or the Faculty Development Program, it is relating to the current trends in the civil engineering. So as a civil engineering, we have witnessed the revolutionary change in its development, say maybe under the ground or above the ground, or shore or offshore, and with respect to conventional use of construction materials. Now the civil engineers, they have shown the advancement beyond the scope and bound. So hence the current faculty development program, it focuses on current trends in civil engineering, highlighting different domains like structural engineering, geotechnical engineering, and then transportation, water resources, environmental engineering, covering various topics on sustainability, reuse of construction and demolition waste, soil exploration, and then application of industrial waste products to treat the water treatment, and then use of artificial neural networks in civil engineering. Now that is the brief of faculty development program that we are going to have. Now, I would ask Professor Vinod to briefly introduce our honorable speaker, Pravinjith sir. Over to you, Vinod sir.
Thank you, sir. Uh, Welcome to Pravinjith, sir. Pravinjith, sir has over the 28 years and more than 350 project experience in infrastructure, energy, and environment. His experience included concept to commissioning, including the design of infrastructure for various projects of green building, sanitization, irrigation, drainage, rainwater harvesting, e-waste, renewable energy, and environmental impact assessment related project. He has experience working with international teams from German, UK, Netherlands, US, Kenya, Taiwan, Thailand, Nepal, Sri Lanka, North Korea, and China in various capacities of trainer and consultant. International organization include World Bank, World and COPA infrastructure, etc., and offered consulting services in 9 countries in various capacities. He has rich domestic experience working across 19 Indian states, 3 union territories, and over 65 cities, extending from Jammu to Andaman, Gujarat to West Bengal. His private sector client included reputed companies like Toyota, Siemens, Tata Motors, Mahindra, Manipal Hospital, etc. Several of the projects designed by him and gave gain national recognition, such as Honorable Prime Minister of India under National Urban Water Award and National Water Award 2018, and Municipal Waste Management Manual prepared by CPHO, Government of India, and Smart and Decision Making Software Tool, and CVEC Samor, and deputed as a team leader. Is elected in STP in Uttarakhand state under the National Mission of Clean Ganga. He has designed and helped implemented hazardous waste TFDF project in Karnataka. Mr. Pravinjith is a civil engineer with a Master of Degree in Geotechnical Engineering from UVC Bangalore University. He also has Executive MBA from the Commonwealth. He is currently pursuing PhD in Municipal Solid Waste Management from VTU. He is also lead auditing from EMS 14,000 and international quality auditing from ISO 9000. He is the life member of Indian Geotechnical Society and chartered engineer and fellow of the Institute of Engineers India, life member of Indian Water Work Association, member of International Solid Waste Association, life member of Indian Society of Earthquake Technology, member of International Solid Waste Association. He is the founder and managing director of EcoParadise, an environmental consulting company. He is also president of Association of Decentralization Sanitation Infrastructure Services Provided. Besides, is associate member of charitable non-profitable organization Swasta, responsible for the optimal utilization of resources and conservation of environmental. Thank you, sir. Welcome to our FDP. Thank you, Pravinjith, sir.
Thank you.
Now I hand it over to Anup, sir.
Yeah, now I request the chief guest, Engineer Pravinjith sir, to say a few words about the workshops and also about these topic, the talk of the today.
Thank you. It's my great privilege to be part of this faculty development program organized by BMSIT. My sincere thanks and gratitude to the principal, the HOD, and the resource people in the civil engineering department. A warm welcome to all of you. The topic of today is the smart city. So I would like to talk on the relevance of smart city in the current context. With the COVID pandemic, it makes even more relevance in terms when you define the word called smart. So the smart city concept actually stems from this need for sustainability, because what's happening is almost the prediction says that by 2050, virtually almost everybody, almost 6.5 billion people would be migrating or living in urban cities. And there'll be a strong pressure on cities to minimize the resource consumption, because by definition, a sustainability means using the resources for meeting the challenges of the present while not sacrificing the needs of the future. So that is what is the main thing. Like we all know, we have not inherited this earth. We have merely borrowed it from our children. So that means if you want the earth to stay long, because after all, we have only one earth, the sustainability part of it has to be strongly embedded in our planning and implementation process. And cities are looked at as the drivers of a national development, because nearly 80% to 90% of the GDP is generated by a urban city. So unless you take care of that, the growth would have to be sacrificed. So in this context, smart cities play an important role, because it's how we use the resources. How do we use the resources in such a way that we minimize minimize the losses, increase the efficiency in whatever we do, and conserve the resources. This is the key part. And I think typically when we look at smart cities, we always look at digital and electronics and ICTs and Wi-Fi and whatnot. And today, in these days, even now this webinar is happening on a virtual platform. So this clearly shows you how dominant the technology has taken over our system. In such a context, what role does a civil engineer play? Or does he get sort of outdated, or can he still find a relevance in the current context, is the theme of today. So with this, I think I think we have got a lot of eminent speakers talking on various subjects over the whole week, and they'll be bringing with them their expertise, their forte, and their experience. And I think it will be interesting to learn from them, because as we all know, people who forget in history are condemned to repeat it again. So it's better that we learn from them and move on from there, what they call the leaping frog, instead of going through the whole evolution of learning and doing and continuing the story. So I think we have a great week ahead. So with this, I would like to welcome once again all the participants, and look forward to this interesting week. Thank you.
Thank you, Pravinjith sir. We are very fortunate to have a chief guest of the today's inaugural function and also a resource persons of this FDP. Thank you once again, sir. Now I request our honorable principal to have some presidential remarks over the FDP.
Thank you very much. My dear Mr. Pravinji, your profile looked very interesting, very good, very broad and deep, very good. I don't think we could have had a better person than you to be here to address all the faculty members of both BMSIT and beyond, and also students here. Okay? Hearty welcome to you at the very outset. I also welcome all the participants from various institutions, including BMSIT and also students, and encourage them to actively participate in this particular faculty development program. In fact, faculty development program, if you take out C out of it, it becomes a faulty development program. I hope it shouldn't happen that way. I would encourage you people to participate actively and gain as much as possible in this whole 1 week session. And I congratulate the department HOD, senior faculty members, and all the faculty members and staff in the department to have taken up a very important topic. Although they call it as recent trends in civil engineering, that's a very huge and very wide one. I'm sure that the topic that was picked up by the chief guest today, that is smart cities, makes a lot of sense for today's situation. And with this faculty development program, you might be interested in developing your competency, capacities, and skills. Definitely yes. And you could be going back to your colleges, probably teaching the same old fundamentals, and also a little bit of trends that are seen already in civil engineering as effectively as possible to your students. But I believe that won't take us too far actually, unless you make people to think of improving the existing systems, bringing innovations. When I talk of innovations, it can be both incremental innovations and radical innovations. In fact, the cities like smart cities cannot be realized at all. That's what I believe in. I'm sure that you will be helping the students to think differently and to think different things also, to make sure that the existing systems of operations, existing systems of maintenance are improved enormously, so that the resources that we have, the limited resources that we have on this earth, can be very sensibly utilized, and we can also make it sustainable so that such resources are available to the future generations too. I'm sure that this faculty development will be a very successful program, and every one of you who is participating in this program will have a great takeaway from this. I encourage you people to interact with the speakers, interact with the faculty members of the department, also network among yourselves, so that any idea that evolves in this particular workshop can be taken forward in the days to come. Hope you'll be able to disseminate the knowledge that you gain here and transfer the skills that you acquire here to your institutes, your colleagues over there, your students over there, so that the whole society benefits a lot at large. This is what I wanted to share with you all. Wish you all the best. Have a great takeaway. Thank you.
Thank you, sir, for your valuable and motivational the speech. And definitely, as our principal always believes in innovations, a sort of creativity, and also the sustainability. Always our principal speak about the sustainability in the present context, how we can the effectively and optimally utilize the natural resources, considering the environment in a eco-friendly manner. So definitely we will take your words, and even all the students and faculty will try to utilize or effectively bring into the fraternity of the civil engineering. Thank you for your valuable words, sir. Now I request our Anup, Dr. Anup Kumar, to have the vote of thanks.
So, let me see. So I extend my kind gratitude and thank you to the honorable principal and then vice principal sir, our head of the department, our faculties, and our honorable chief guest, and then and all the participants. Thank you one and all, and welcome to the faculty development program. So the topic of the presentation is the smart cities, okay, and then role and responsibilities for civil engineer to how to maintain the smart cities. And the topic will be delivering by Pravinjith sir. Okay, let us begin the session with your kind request. On to you, Pravinjith sir.
Thank you, Anup. Again, a warm welcome to all of you. Good morning. So I'll take you straight away to the presentation. Let me share the screen. Is it visible?
Yes, sir. It is visible now, sir.
Yeah. So today the topic is the smart city, the prospects and role of civil engineers. Like I informed in the earlier speech, typically we look at smart city from the digital angle, from the technology angle, from the ICT angle. So most of the cities are always with some sensors or Wi-Fi enabled, Bluetooth, and that's the typical thought which immediately runs to us with video cameras. And so when you're looking at it, it looks like smart always means something to do with computers and IT. And civil engineering is one of the oldest branch, and it works with the brick and mortar, soil, and stuff which somehow does not fit with the current thought process of smart. Or is it true? Or is there something else which we are missing? So that's the topic. So smart city, like I told you, it stems from the fact that sustainability is the key parameter on which the world will move on from now. It means the development that meets the need of the present without compromising the ability of future generation. So now this is a political statement made by and agreed and endorsed by the UN. Reason is they all recognize there's only one Earth, and time to colonize the Mars and Moon would take long time from now. Until then, we need to survive. So they have sort of encapsulated the vision in 17 goals. 17 goals which ensures equity. That means everybody is part of it. Nobody is left out for either want of education, health, or race, or language, or there's no barrier as such. Everybody on this planet Earth has to be benefited by this SDGs. So that is the 17 SDGs, which starts from no poverty to something like clean water and sanitation, gender equality, to reduced inequality, sustainable cities and communities, life on land, life on water, and climate change. Now, if you look at it, all of them they're not separate islands on its own. They are all interwoven. It's a complete web where somehow each one sort of reinforces the other. That's the key part. And how the sustainability is built on, the house of sustainability is built on 3 pillars. Key thing is environmental, social, and economic. Now, any one of this pillar is short or long, the whole sustainability house will fall. I mean, as civil engineers, we know what it means. The pillars have to take, all of them have equal role. So nothing which is little more or little less. But somehow the social and the economic part is actually embedded in the whole environment, because environment goes beyond human beings. So this SDGs have 17 SDGs have totally sub goals, about 169 goals, which if you meet, we can hope to achieve what we call sustainable. This is from the human angle. Now, the smart city definition is A smart city is an economically, see all these red bullet things have to be remembered. It is an economically vibrant city that provides a citizen, it's not a dull, it's a vibrant city that provides its citizen a good quality of life. Now, quality of life can have many definitions, but a good quality of life using application of smart solution. See, smart solution is a keyword. Use of smart device and digital technology. Unfortunately, most of the time we lay an emphasis and stress on the smart devices and the digital technology, whereas the actual operating word is the smart solution. So that's the important thing. It should be economically sustainable. It provides all its citizens a good quality of life using application of smart solutions. And the devices and technologies are actually a tool for achieving it. So it's like your calculator and computers and mobiles. It's a tool, but the solution is the key part. And the important part is a smart city cultivates a better relationship with citizens and governments using available technology. So there is a two-way flow of information between the citizen and the government. If you look at it some 10 years ago, even 10 years ago, the information was always one-sided. It's like the radio, Mann Ki Baat, one side the information comes, you can't respond immediately. But today, you can actually, with the social media, you can actually correspond, communicate with the government. The government can on real time inform you what's happening. So this helps you to improve service delivery. You can see a lot of helpline, WhatsApp lines, which you can register your complaint, and the information also comes that they've taken action on it. So these are the important part of smart city definition. Now, so here we apply electronics and digital technology, like we all know, but key part is we use information communication technology to transform life and working environment within the region. This is the key part, transform life and working environment within the region. Now you look at it in the pandemic, a lot of people are working from home. You are having classes at home. So you're transformed and you are able to react to changing circumstances with a very less response time. No? So that makes you a resilient system. The system is resilient. It can take care of any eventualities which can happen. Then embedding of ICT in government systems. Most of the things are in ICT. So if you go to Bengaluru 1, for example, earlier you had to apply for a khata, you need to apply, send and wait. Now you can get your khatas, you can get your birth certificate, you can change your name, you can change your photos. A lot of things are happening online. You don't really need to go anywhere to do things. So the ICT is well and part and parcel of the current systems. Your billing is possible, and you can also make your payment to your utilities like electricity board, water supply, taxes, all are online. So these are all very useful when it comes to making something, making what we call a smart city. And methodical organization of practice that brings ICTs and people together to enhance innovation and knowledge. So this is some definition of Deacon Ware. There are many other definitions. Smart city is one that uses ICT to meet the demands of the market and the community involvement necessary for a smart city. So key part is demands of the market and ensuring community involvement. Then smart city that has digital technology embedded across all city function. So that means the governance part, digital technology is embedded. When investment in human and social capital and traditional modern communication infrastructure fuel sustainable economic development and high quality of life and a wise management of natural resources through participatory action engagement. So this is one of the very comprehensive definition where whatever you invest on human and social capital, you are not foregoing the traditional modern communication infrastructure. And the key word again, sustainable economic development, high quality of life, and a wise management of natural resources. This is very critical, and through participatory. So it is not top-down approach where the government tells you do like this. It's not like communist China or Korea, but it is that everybody, you are actually in a consultative role. There's a participatory function and engagement. So that's the key part. So the smart city involves these key words. So that's something, whatever we do, we have to see whether it affects human beings, the social capital, whether you are fueling sustainable economic development, ensuring high quality of life, and you're using wise management of natural resources. This is very critical, and through participatory function. Okay. Now the Government of India definition is smart city offers sustainability, keyword in terms of economic activity. So economic has come in, employment opportunities to a wide section of its residents. So equity is coming regardless of their education, skills, or economic income levels. So the key part is economic activity and employment opportunities to a wide section of its residents. So that means equitable distribution of opportunities. So nobody is excluded, what we call Sabka Saath Sabka Vikas. Now, this is the Government of India's definition of sustainability. Now, this is another definition. This is very important, and this slide will keep coming often. So the 8 key aspects are smart governance, all these ICTs, your Bengaluru One, your digital payment, all these things is part of smart governance. Smart energy, smart building, smart mobility, smart infrastructure, smart technology, smart healthcare, smart citizen. So this is what makes a city smart. So you can see in the smart living, we have sewerage sanitation, water supply, electricity, housing, citizen safety, public open space, smart environment, pollution, green building, renewable energy. So all this together forms a smart city. Of course, you can add more and more components to it. As and when we find a problem, the solutions would be finally the smart one. Now the question is, the smart city, why city and why smart? Why not smart village, smart countries, smart towns, smart houses? Well, what we know is, if you see this map, India urban population is expected to grow to 81 crores by 2050. India is right now 130, might 2050 to go to about 180 crores. Now, almost virtually more than half would be in the cities. That's the key part. And world over, right now the population is around 7.8 billion. Almost 6.3 billion is expected to be in the urban cities. So you can see the brown color, the light blue, and the yellow. They are this 40 to 60% percentage of urban. And where there's no urbanization by 2050, 2030 is that blue color thing, a small patch in Africa, and that little green, 20 to 40%. You can see some part in northeast of India and some part in southwest. But if you see, there's a very minuscule part of it is the non-urban thing. Rest, all of them are across the 40-60 percentage. So virtually every city would be, I mean, every square foot or square meter of land would finally be urban by 2050. This is the key important part. And more people are living in cities, and people are transiting from the agricultural economy to an industrial society. See, when India got independence, they said Mahatma Gandhi said India leaves its village. Now there's no more village. Most of it are becoming urban part. So we are moving towards industrialized societies. So we are not going through the usual evolution of a country from an agrarian to slowly to an industrial. What we are doing is we are learning from developed countries. We are just leapfrog. That means we are not islands. And one classic example which I can tell you is, you know, these emission standards, no? Usually have the BS1, Bharat Stage 1, 2, 3, 4. And the world, we jumped from Bharat Stage 4 directly to Bharat Stage 6. We did not have a BS5. Reason is we don't want to learn slowly and improve and evolve. We want to go one step ahead and be waiting for the future, making ourselves future-proof. So that's what countries are doing. Every country is trying to leapfrog into the future so that we don't want to have that usual pains of development. And all urban cities, they are the growth engines. Nearly 80% of the GDP is coming from this city. So if the cities develop, the state develops, the country develops. So your productivity is more, your local economy will increase, the job creation. Why do people migrate to city? Because of jobs, because they know that the cities offer job. So if this city does not or stops offering job, then you have a problem of unemployment, which means you need to maintain this engine of growth, prime it and keep it running. And because of which environmental impact, urbanization, the fallout of this high pollution is, you see it in Bangalore, you have high pollution. And what this pollution causes a lot of other things. The first definition of quality of life gets affected. And it is more problematic for people who are not in the higher end. So that means equitable thing is not happening. So the vulnerable area, community, vulnerable people get affected more with this with the city being urban. So what it means is, when you make a city smart, we can ensure that this development transcends all these barriers and everybody gets to live the same quality of life, which is good and it's always positive. So accessible, health and mobility, all these are part of the smart city. How do you do it? You see some of the examples. Energy, you have smart meters. Typically, you would have seen earlier, you have the street light glowing even in the daytime. Now you have this smart switching off, which senses the daylight and switches it off. Smart meters, which prevents people from using electricity, unbuilt energy, for example. Or it can also give you an idea about when you are consuming more power, which means you can take a decision of offsetting it by some other strategy. This is possible. Meters which do not allow stealing of power, for example. It can also ensure that the people who consume more power during peak times are penalized. So we have time of day metering. So a lot of things are possible because we understand the energy part. Transport, you have advanced traffic management system. It can sense the real-time traffic data. Your Google map, when you put, you see the red things which shows there's a traffic jam, and it tells you an ETA which is longer, so you can choose a less congested route even though it's longer, or thereby reducing your travel time and also reducing the pollutions. It can also, yesterday's paper there was something about this intelligent traffic signals which can sense the pollution, the traffic congestion, and also adjust the timing accordingly. So you would see, typically in Bangalore, you would come to a junction on a traffic and you have the red light facing you and there's hardly any vehicle on the opposite direction. And you'll be wondering why, and you will still wait, and then you see one or two fellows who are just trying to beat the signal and going, and then some accidents do occur. But you would then wonder, if a policeman is standing there, he can actually do a real-time traffic management. Now, you can't have policemen, so can we have technologies to manage that? Well, that is what is the advanced traffic management system. Your building management system, which knows how to heat it up. So it takes power when it is cheap, and then cools the building and keeps the building, maintains the building colder or cooler, so that you save on power. So there are many ways of doing things. Waste management, which have sensors which tells you that the bin is full, so you don't have to wait for or just open bins and access bins even though they are not full. So making the transport and collection and transport more effective. Same thing with healthcare, So there are a lot of examples on how you can make things smart. So it's answer on how society and its resources can be organized so as to create best outcomes for present and future generations. So these are all various examples of how things are smart. So what it means is, typically we see what is the input efficiency. How do we increase the, so the typical resources are finance, your human resources, land, energy, all this would be your input. Then you see whether the output is effective. Are we getting the best value for money in terms of energy and water supply, in space, wastewater management and all. So this is what, when you measure the input and measure the output, you really know the efficiency is there. But then, is it really positive? That is from the user's perspective, is the outcome viability. So when anything you do, until the user perceives this as being useful, the outcome is not really viable. So the positive impact is necessary. So that is where this smart city starts functioning, because you are sending the information on real time to the clients. So the components of a smart city, you have the core infrastructure. It ensures high quality of life, and all the solutions are overlying the basic amenities, and a clean and sustainable environment is embedded in it. So you see this smart living, smart people, smart mobility, smart environment, smart economy, and smart governance. So you see this six baskets or buckets of components where we can ensure smart city. Now, why is technology so relevant? Technology is, we all know, you can't manage what you can't measure. So when we say that we want to improve the quality of life, when you want to minimize the natural resources or use of natural resources, until you measure what you're using, you can't, or you don't measure what is your output, you can't improve. So what we do is, instead of putting a human being to measure, we are using technologies to measure the input and outputs. So it integrates ICT and physical devices, sensors, and which is connected to the Internet of Things cloud to optimize the efficiency of a city operation. So these are, and now what's happened, the sensors are quite cheap, and a lot of, you will be surprised if you go to some of these Amazon, Alibaba, and many other things, the type of sensors which you would not have thought. There are something which can actually replace a dog in terms of smell. No? So these type of things are available, and people have sort of woven things together to make do something and solve a problem. So they are processed and analyzed to monitor and manage traffic, transportation system, power plants, utilities, water supply network, waste, and safety. So all these things are available, and it also allows the city managers to manage assets, resources, and services efficiently and operation across city. So with this, you can see the number of policemen on the road is less, because you have got those cameras there which can just take a photo of any violation, and there your vehicle with number is already available on the BTrack site, and where you have to go and pay the penalty online. So everywhere it is sort of, the system has taken over so much that it can ensure regulation of certain things, optimization of usage of resources. So all these things are possible with ICTs. So what has happened is, Government of India started the Smart City mission in 2015, where they thought of bringing in some lighthouse projects which will serve to showcase technologies and demonstrate how a smart city benefits from this, and which they thought, if you have such lighthouse projects, others could emulate them, copy them, improve upon them, adopt and adapt. So it will, so the whole country will reach, because we all have to be prepared for the 2050 when most of India would be urban. So now, right now, there are about 100 smart cities, and each one is doing something which they perceive as the most important for them. So it's not that everybody puts their focus on transport or in energy. That is where the participatory function of the city comes in. See, if you see the opening in the opening slide, participation of the city, the citizens are important. So the community have decided what is key for their city. So if you look at a Bengaluru would say transport, traffic management is one of the most important part in Bangalore, because we always talk, Bangalore is probably the only city which talks in scientific terms and distance. We talk in, in science, we talk, typically the distance unit is kilometer and meters, but when it comes to astronomical or scientific thing, we talk in light years, in time units. Bangalore, when you talk about the place, we always say it is half an hour away, or it is 1 hour away, or 2 hours away. It is not really distance. It takes 2 hours to reach here. So it's something like it's a time unit which is used. It's probably the only city in the world which talks like that. So traffic is one of the most important problems in Bangalore. Your polluted water body is one of the most important problems. Water scarcity is one of the most important problems. So you see, every city chooses what it thinks is relevant to itself. And how we work? In the smart city, we work on the area-based development strategies. We can redevelop an entire one project with an existing things. You would see some of the slum development projects are like that. We are slum projects where they do an in-situ development. You can also do retrofitting, where existing infrastructure is largely retained and then something is built around it to overcome the problems. It could be a completely greenfield project where everything is new. So these are the 3 strategies adopted by urban planners. Now, having said all this, we understood that technology is very important. Participatory role is there for citizen. We decide what is important for a city, and it's mostly technologies which play a role. Now, in such a context, what is the role and prospects for civil engineers? Now, civil engineering is quite important because 40% of the building industry produces the largest amount of demolition waste and also contributes largely to the greenhouse gases. And 50% of the national waste production comes from the building sector. And the concrete making itself is a large accounts for the largest CO2 emissions. And they have a leading role in playing and designing a building. Of course, architects also do the designing, but putting shape to it, making it finally from a paper project to a real brick and mortar structure is the civil engineering job. And it ensures a sustainable future by providing the bridge between science and society. So if you see, they contribute majorly towards the sustainable development. Reason being, most of the problems are in our area. The others can come out with some tools which can help solve the problem, but the problems itself as normally is dominant in our sector. So if you see this, I have put a circle around smart living as a component. The whole of the smart living, most of it is a civil engineering issue. So if at all anybody can solve this problem, it is a civil engineer. Now, if you look at smart mobility, again, it is a domain of the civil engineer. Smart environment, pollution, green building, renewable energy, this is again a civil engineering domain. And the rest, well, somehow it also helps. There is some role for civil engineers, but I would not put it a predominant role there. Now you look at it, when you're looking at sewerage and sanitation, what can we do there? You can primarily introduce let's say waterless urinals, your low water seal toilets, which will all help in reducing the water demand in the building. Water supply, your dual plumbing. How do we have rainwater harvesting there to augment your water resources? Electricity, use of renewable energy, and minimizing the need for air conditioners or heaters. All this would come in civil engineering. Electricity, primarily, you may not generate electricity, but if I can design something which sort of obviates the need for use of electricity, well, that's a fantastic thing. So your natural daylighting, the use of glass, and fenestration, this one orientation of the building, all these things would help in minimizing daylighting requirement. Use of materials with low U value, which will ensure that your building is temperature controlled or comfort controlled. That would also reduce the need for electricity. So that's something. Housing, use of recycled material, alternate materials for housing, and that would also come under smart living. Citizen safety, somehow it sort of overlaps into some other sector, but there again there are many aspects of citizen safety which you can bring under civil engineering. Public open space management, how do you handle stormwater in a city? See, if I take the context of Bangalore, when it rains, you find most of the places are overflowing with the stormwater drains are overflowing. Some places are submerged. You have the national disaster team coming with boats in Bangalore to rescue people stranded in a building. All these are possible if you can do a very effective planning of stormwater management. Your nalas in Bangalore are sort of polluted. So how do you handle that? How do you handle urban flooding? So all these are part of smart components, which a civil engineer has a direct space to play. Education, health, education, all of you know what we can do. We are all now part of that. Health, well, again, health is a two-way process. Civil engineers play a major part in preventive health thing. Now, people think of health always as frontline workers, doctors and hospitals, but no. If you're looking at solving wastewater issues and solid waste management issue and air pollution issue, you've done a great job in the sphere of preventive health. Entertainment culture, well, that it's sort of imagination on what you can do. I'll show you some projects where we have done, and various other activities where civil engineers can come in here. Smart mobility, I've already spoken about in the transport sector and traffic and walkability. Today's paper talks about India government wants to reduce nearly 1.5 lakh traffic accidents which occur annually. Now, and three elements they put here is behavioral is of course definitely one part of the issue, but they also talked about engineering part, the design of roads and infrastructure, and implementation part. So if you look at it, two aspects of it are in the domain of civil engineering. Preventing accident, that means ensuring life. So sometime long back, we had done a study for analyzing the traffic accidents in Bangalore, and we realized some of the problems can be alleviated by just scientific design of or improvement of road curvature, vertical curves and things. And some government bodies are also taking steps to improvise on such issues. So this is something which a civil engineer can do. So if you can prevent it from the first in the planning process, then we have solved it. Otherwise, understanding it and then solving it is also one of the things. So for this, we have to analyze data. So this is where again the ICT part of it comes into picture. Traffic, I already spoke about in the signals, in the B-track, this one with the Google. Walkability is, if you see the Bangalore tender-assured roads, and most of the roads, you are ensuring wider footpath with hardly interference, which is sort of disabled friendly. So all these are part of the mobility. Disabled friendly is important because if you see the definition, it has to be supportive of all sections of people. So it should not limit to a certain type and able-bodied. It should be suitable for everybody. So these are all part of smart mobility. And pollution, definitely our domain, civil and environmental. So you can stem the pollution right from the inception. You can also solve it because you have the tools to remedy such problems. Green building is one aspect. If you do it, it is a small subcomponent of a smart city. If every building is green, the city which comprises of the buildings would be a smart part. Use of renewable energy and making it part and parcel of the planning process would be ensuring smart environment. IT connectivity, online citizen service, of course, this is governance. Typically, this, if you look at it, if you enter an apartment these days, you have right from your permissions to access, everything is connected on the app. So somehow you can integrate it, dovetail it with your planning process of your building. Employment opportunities, yes. There are a lot of employment opportunities which do come up because, like I said, for everything you start with data, you analyze, and then you have a problem, you find the underlying causes, do a cause and effect study, and then you can find a solution. So the data analysis and then auditing, all these things form a very it's a very important and neglected part, which is now opening up because of this smart city aspects. Now, some of this in sewerage, for example, you have small bore sewer lines. You would have seen, many of you would have got disturbed in cities. You have excavations for sewer lines and pipelines, and all that can be sorted out if you go with small bore sewers, which do not require deep excavations. It can be done in narrow roads. And that's something important. And wherever you have gradients and rocks and water tables, you can go with vacuum sewers type of technologies. You have decentralized STPs, which is anyway part and parcel of the law. You have online sensors for STP, which ensures that the STPs are working properly and complying 24/7. You have waterless urinals. You have aerated faucets, which can ensure less water consumption. You have trenchless construction. So all these are part of how you can adapt smart solution in your subject. Water supply, you have 24/7 water supply where your water wastage is less and you don't have to stock water. See, all you have to understand in many cities, people build sumps. So every time you have almost 6,000 to 8,000 liters of water stored. It's water which is stored just like that. And that is not necessary. So you don't have to pump water when it's really not required. You need 500 to 700 liters per day, a family of 5. So that's all. So you can do an equitable distribution with 24/7. So what happens is where you can minimize the pumping requirement, your water storage structures, your pressures will be sufficient. Same thing with desalination. Wherever you don't have access to potable water, there are technologies which can ensure that your saline water is desalinated and you get for drinking, especially ideal for coastal cities. Smart water metering, which ensures that the people who consume more water would be penalized instead of a block type of billing system, which sort of puts the rich and poor together. It's not right. And the or water wise person is on the same level as the person who is not very wise. So the water metering ensures that the people who are misusing water will be charged more. Online leak detection, which ensures that your water is not getting wasted. You have, after all, bought it from close to 100 kilometers and treated it, and then you don't want 50% of your water being lost in ground. So this is something which you can do, online detection. Rainwater harvesting. What you see here is a good solution for stormwater management and harvesting system. So this is a structure which is excavated and laid in excavated thing, and your vehicles can go over it. So this is one system which I've shown. There are many such solutions which take care of typical problems and solve it. Energy, how do you minimize energy? You have solar passive architecture. You have earth-air tunnel, which can create comfort conditions in your building, thereby obviating the need for use of an AC or a heater in these different seasons. You have solar passive extractor, which will sort of vent out the hot air and the polluted air out without use of power. You have solar chimneys which can handle that. Then you have some aerated concrete blocks and all, which can actually help in temperature conditioning of the buildings. So these are some stuff where a civil engineer can rely on to minimize the use of energy. Smart mobility, we all know the FASTag business. You are told you can pass through. You have those elevated parking, multi-level parking. The parking, parking system which has been smart parking, which has been introduced in Bangalore. So these are all things which we can actually rely on to ensure your road has a more conversion. It's efficient. Road is more efficient. It's not blocked by people who are just parking their vehicles here and there. More orderly parking, and whoever is using it has to pay. So that's the advantage of the smart system. The cycles. Which can be, so the shared cycles, shared bikes, these are all ideas which can help remove most of the vehicles from the road. You have this rapid transport system, BRTS, where you have the bus alone, so that you're sort of disincentivizing private vehicles and popularizing mass transport. That is one. And then if you look at the smart roads, you have conduits. So you don't have to really excavate whenever you want to lay a new line. You already made planning for it. Your sewer lines, your water lines, your electrical utility, you won't have cables hanging from trees, almost sort of strangulating you with your OFC cables, from internet cables hanging from trees and electric poles. No, you can always design it such a way that all this can be just wired as necessary. You already planned for it. So that is what is the key aspects which you have to think when we look at this retractable bollards, which can so instead of this manual barricades with the police lift. So you see, on one side you have a vehicle going, on the other side the traffic is virtually, the lane is free. Now you can see that typically between Bangalore city to electronic city, the ITPL, you have traffic always on one side, and return you have the traffic coming on the other side. So just imagine a case where the dividers can actually move and give you a larger width where the traffic is more, and then shrinks in the opposite direction when in the reverse direction. Now that is not possible with this concrete physical barricades. Imagine you have these bollards which are retractable at placed differently. Your lanes can have different widths at different points of time. It's just a concept. Now all this are possible with this smart city type of thing. So you have this intelligent signaling where it senses the traffic and then times your signals accordingly. So this is something like you get your plastic PET bottles, you can give it, you get your credit. So these are all started in India. It has been there abroad. So where you can exchange your waste for some cash or kind sort of rewards. So this is already there. Then green buildings, you see the building on the other side where I understand it's about 80-meter tall building, and they have almost 3 hectares of greenery on that building. Now you see what happens with building is that we remove a space which was otherwise occupied by plant, and in a bid to provide housing. So when you do that, that amount of land is not available for greenery anymore. Now, so how do you compensate? The roof is anyway there, the sunshades and these vertical faces are always green. So you introduce this greenery, trees and shrubs. It will also sort of, you can probably amplify the amount of footprint you have removed, one. Second, it can also sequester carbon dioxide, it can filter pollution, and it can let off oxygen. So there are many advantages with such a green building, plus cooling the building and also encouraging the biodiversity of bees, butterflies, birds. All of this can thrive on this greenery. So that's something which we can do. Renewable energy is not always solar. You can also have renewable energy from waste management. Your solid waste can be a biogas source. It can offset the requirement of fossil fuel, your LPG. You can also have power generated from this biogas. So there are many options here also. All these are part of a civil engineering aspect. Now, a small brief about us. EcoParadigm is an environmental consulting company established in 2006. We operate primarily in the field of water and wastewater, solid waste, energy, and climate change. And our services span right from research and planning to consulting, implementation to optimization and environmental and social impact assessment. Now, the reason, and I'm going to showcase some of our projects which somehow qualify or fit into this definition of smart cities. So you see this one, I think Anup already made a mention. We have got 300 plus projects in the last 15 years of existence. We have worked in almost 9 countries on invitation from World Bank, United Nations, and other. We are a civil engineering company with professionals from the civil and environmental, and also encourage a lot of interdisciplinary projects. So most of the projects somehow transcend the definition of the conventional civil engineering. Yeah. So some of our prestigious projects, you see, we have been part of the technical team which authored the solid waste management manual published by the Central Public Health Environmental Engineering Organization, Government of India. We have developed the only software which is available on the Swachh Bharat mission. It is a decision-making software for choosing the best technology for managing solid waste, municipal solid waste in a given context. The third project, the Waste to Energy project, is a first of its kind project which handles both the wet waste and the domestic fecal sludge from septic tanks in a single treatment plant and generates almost 250 kilowatts of power on a daily basis. What you see is a hazardous waste transport, storage, disposal facility developed for Karnataka in 2008, and we have been involved in the concept and commissioning of the project. And now recently in March 30th, we actually commissioned one more TSA for the state of Goa. These are some of these projects which we have got national recognition. One we got from the Honorable President of India in 2009 for a treatment plant in Mumbai, and the first prize at the National Water Award 2018 for a lake rejuvenation project in Bengaluru. We have also worked with the German government, UBA, is a Ministry of Environmental Management, in developing a resource and climate protection for integrated waste management for India. So these are some of our projects which typically do not fit the definition of a civil engineer. So all of you as civil engineers will always remember structural analysis, fluid mechanics, concrete technology, structural steel, soil mechanics. This is the usual definition of a civil engineer. We don't look at ourselves as fitting in most of this bracket, and this is a key component that civil engineers can play, because and you will finally realize that virtually 80 to 100% of the thing can only be done by a civil engineer. All you need is to learn the other branches of civil engineering. They will become, other branches of engineering, and they will prove to be an aid for you when you in your professional life. Some of our clients, you can see World Bank, the UNDP, UNICEF, the German International Corporation, Karnataka Police Housing. Some of the private sector clients, Ernst & Young, one of the big 4, they say, Manipal Hospital, Toyota Kirloskar, Mahindras, Marthas, Karnataka State Cricket Stadium, PepsiCo, they're all big names in their own sphere. These are all some private sector community clients. So some of the projects, I'll just go quickly to this rainwater. We all know when we heard of the South African story about this water being rationed, where people are getting around 25 liters per day, per week, per person. And they were saying that the day zero for Bangalore is the next one. Bangalore would be the place which will have water scarcity. So India is, in general, has already reached the stress line, water stress line, which is 1,700 cubic meter per person is the standard, and we are already at the stress line. So how do you do rainwater harvesting? So this is some of the projects which we have worked with. This is a Toyota project, about 92 million liters harvested per year. So this is something which we have done at the Chinnaswamy Stadium, where cricket, typically when it rains, when the matches get washed out, they lose a lot of money. A lot of audience also get into sort of shock when the matches get abandoned. Chinnaswamy Stadium is one where you can start the match within 15 minutes. It will be bone dry. And in terms of economics, it makes a great deal. So they have introduced something called a sub-air system, which is also a smart technology to sort of drain away the water and aerate the water and make dry it up in 15 minutes. Yeah. So this is one. And this is our project in Toyota Kirloskar, where they recycle 90% of the water. And that means to that extent, they are off-grid, we can say.
We at TKM have reduced our carbon dioxide emissions, and freshwater consumption in our operations has reduced by 90% on account of our rainwater harvesting and recycling facilities.
So this is our project where we got the national award, where the nalas which are polluted are treated naturally without power, and the treated water fills the lake. So this is a project in Kundalali. Of course, we have done 6 other projects for the BBMP, and this is the Kundalali project. This is one more project which we done with the Ports Authority, where we audited and did the environmental assessment for water management for all the ports in India. This is a river pollution where we are handling, giving strategies on how to reduce river pollution. This was under the National Green Tribunal as one of the most polluted river. Last year there was a lot of problems in Kerala, and because of domestic sewage entering the river. So we made the Karamana River Action Plan for Kerala State. So you see, these are the conventional way where we acquire data. See, that's something which every civil engineer knows. There's nothing special about it. But sometimes, due to paucity of time, we do not really take note of this data point. So for the civil engineers in the 7th semester and 8th semester who have gone for the old tank, new tank type of projects, they somehow look at it like more from an excursion or a picnic point of view. When the other branches go for industrial visit, these people are forced into some subject like this, but they don't realize the value of what they're doing. So this is something which we do. It also involves consultation with people. So this is some place where technology cannot really substitute. You need to have the human connect, and that is where the civil engineers have a greater advantage as such. So this is something, and I told you about capacity building awareness. We also find smart ways of embedding the concepts, the vision, and the definitions of environment through games. So it's called gamification. That's also a smart way of teaching. So we have this in our we have done this for solid waste management on behalf of the Government of India. This is something which we use. You know, the waste which is being picked up from the houses. Right now, the vehicles have GPS tracking, so we really know if the vehicle has passed by your house or he has just given a skip to your house. That is possible to see. So that actually helps in efficiency and improvement of solid waste collection. But there is, if somebody gives 10 kg, somebody gives 100 kg, somebody gives only half a kg because he's really clever and he's really environmentally conscious, you're all charged the same amount of money, you know. There is no way a polluter can be penalized. So this is an innovation which we have developed in our office eco paradigm. It's called SEVAK. SEVAK means assistant. It also means segregated waste accounter. So this also tells each house how much they're giving, whether they're giving segregated waste, if so, what part of segregated waste is, how many kgs. All these things are known real time. So if I put a threshold limit, I can say, tell me in this route in Koramangala, the number of houses which are generating more than 10 kg, I can actually get a short list. So then we can go and create awareness to them. You can tell them, look, everybody is generating only half a kg or 1 kg. You are abnormally high. So understand and educate. See, these things are not really meant for sort of policing people, but actually a tool to aid. So like I told you, what you can't measure, you can't manage. So since we can now measure, I can find out who is producing what waste at when, and are they mixing it, are they giving it segregated, and which type of material is coming predominantly and when, which time of the year, which season, and which day. So because waste also goes up and down during daytime, during the week. So we can actually plan for resources. It's not always 4 autos in one ward. It's not like that. So you can increase the number of auto rickshaw at a certain time. You can prepare yourself to receive waste whenever you want. So this is this particular innovation won the International Science Festival Best Innovation Award in December 2020, and it was also judged the sort of runner-up in the for the Smart City Awards, just concluded last month, and then so that's a success for us. And mind you, this is from a civil engineering company. This is another software which you have made for solid waste management process for the Government of India, which is in the final stages. This is the waste to energy project, which digests both fecal sludge and septage and solid waste and generates power. This is a smart way of handling. Instead of having one STP separately and a solid waste management plant separately, we combine both the projects into single one and solve 4 problems at the same time: management of solid waste pollution, management of wastewater pollution, generation of electricity, and financial, because it is economically very viable. It sort of pays itself. This is an app which we have made for managing the hazardous waste from generated from industry, which can also do the similar thing like SEVAK. It can also flag companies which are generating more than usual. It tells you which waste is coming when, because some waste are also the neutralizing waste for the other. So we can actually plan in such a way that you can pick up 2 complementary waste, so that your waste management cost comes down and your landfill life gets extended. This is another one, you know, the typical, we have this Prevention of Manual Scavenging Act. So it encourages you to pick up waste using mechanized vehicles. But after that, they take it and discharge it in a nearby water body or in the farm, which will pollute the groundwater table. So this is an innovation which also reached the top in the Maharashtra Swachh Maharashtra Mission Challenge Award. And this can prevent unauthorized collection and deposition of fecal sludge from septic tanks, and also help you plan the optimal functioning of a sewage treatment plant or a fecal sludge treatment plant. So this is another innovation which has been developed from our company. And this is a treatment plant which I told you won 2 national awards. One which does not require chemicals or energy to run, and it treats to the current standards of less than 10 BOD. Does not require daily operation. So it's a very smart way of operating an STP, because it does not require human beings to attend to it. So this is one of the larger projects, and the operation cost is just 1 lakh for a 1 MLD project. In comparison, if you wanted to use a conventional system, you would be spending anything like 2 lakhs to 2.5 lakhs per month to run a similar project. This is another under the to skill enhancement program which we are developing for the Government of India. Various training programs where things are taught online. And to summarize, the smart city agenda entails improving the citizens' quality of life. So again, quality of life, strengthening and diversifying the economy, and prioritizing environmental sustainability through adoption of smart solutions. So the smart city itself is not a destination. So now somebody cannot say this is a smart city. It's not the full stop. It is a journey of continuous improvement. So this is something which we have to remember. It is not an end by itself. So nobody can call something as we have reached the smart city thing, because technologies keep changing, problems keep changing. What was currently a problem, once you solve it, something else will open out. If you remember, it's like Tom and Jerry's cartoon, where if you press a balloon on one side, it will start blowing up, and balloon on the other side in a hose pipe. So that's how it works here. So this is something we have to understand. It's a destination. It's not a destination. It is a journey. So we have to be continuously keeping our skills sharp, finding the technologies which can solve our problem, and also keeping an eye for a problem. See, typically civil engineers are sort of blinded by the usual problems. They don't try to go beyond it. So the current problems can be solved easily, and then you have to look forward for newer challenges and then try to integrate. And my clear recommendation is we have to erase this definition of civil engineering or any other engineering. There's nothing called, it's pure engineering. That's the only thing. And once you get into professional life, whatever you've learned, every bit of your subject, 48 subjects or 52 subjects which you learn, everything else is like a beautiful pearl string. You miss one string, it will look like it won't be a beautiful ornament. No? So you can't forget anything which you learn. That's something which I keep telling all my colleagues and the interns who come here. And by itself, you cannot be a frog in the well. That's the key important thing. Your well is not the world. The world is much bigger than that. So you have to jump out and see what are the branches help you perform your work better. So that's the key part, the key message. But here I would like to stop and ask you to think. See, like we said, having data is always good. Now, this equipment which you see is a Holter equipment which measures the changes in your heartbeat and can diagnose and tell beforehand. Because you are monitoring, you can tell that whether you are liable for some heart issue. So this is a portable instrument which you can stick to your body and walk around, and it will be continuously recording your information. It can relay today's world. It can relate to your doctor. Imagine you are 7.3 billion people having this. The doctors can, with the technologies, identify who is going to have an heart attack or land up in a trouble. This is possible. Same thing with this oximeter. No? In this pandemic case, we are all talking about oxygen. You can put it, and if your oxygen level falls down less than 92, you know you will have to go to a doctor. You can continuously monitor. This is there. So with ICT, this is very much possible and very much feasible also. It's so cheap. But then, is this the thing what we call as smart? Like Einstein said, any darn fool can make something complex. It takes a genius to make something simple. So smartness is not making things complex. Smartness is not putting sensors all over the place. Smartness is not acquiring information for information's sake. Smartness is trying to see whether you can live without all this. No? So if you look at nature, the best teacher, nature is pleased with simplicity, and nature is no dummy. Nature has lived there more than humans. And the yoga there clearly tells you, if you are having a well-placed lifestyle, you don't really need to have such technologies and governing your life. So this is just a food for thought. Where do you draw a line in introducing smartness? Thank you. I hope it was interesting, and any questions, I am there for you. Any questions? Yeah, one question. Can we facilitate all the said technologies in the village? Yes. So the technology does not have such restriction. It can be done. But the question is, like I told you in my last thing, what are the problems which are, can we sort it out? We are currently working with one project which is it's called ProSoil, or Urban Rural Nutrient and Climate Change. This is a very interesting project because in the villages, the farmers are having a major issue with depleting productivity in the field. So the product yield is reducing over the years. And one of the strongest reasons why this is happening is the carbon is reducing in the soil. The carbon is reducing, and use of commercial fertilizer have actually shown that over the years the yield has reduced in whatever agriculture you are practicing. Now, so the carbon is, the farmers supplement the carbon by taking farmyard manure, which is cow dung manure or any horse dung or anything, something similar to that. So they replace it with farmyard, but they don't get adequate quantity of farmyard manure because there's a shortage of that. So now shortage of carbon sources prevent the yield. Now that is one part of the story. Now, like I told you, urbanization is increasing, which means more and more agricultural land is becoming residential areas. So you're, on one hand, your land required for agriculture is reducing. The people employed in agriculture is also moving away and becoming a city dweller. So you have farmers on the lower side, the agricultural land on the lower side, and the yield also on the lower side. So you see, you have a burgeoning city population which needs food. But on the other side, you don't have food at all. The food yield is coming down. The farmers who grow the food are also reducing. They're all shifting their professions, and the land is also reducing. Now, how do you solve this? This is one story. The other side, as a city increases, your wet waste is increasing, and one of the technology of choice is producing compost. Your compost is increasing on one side. If you manage solid waste well, you have got compost production, which is on the other side. So you have a compost which is a source of carbon. Now the problem is, this source of carbon is in the city. The people who need carbon are at the village. Now you need a system which sort of bridges these two and produce and sort of link. So that's a smart way of doing things. So we are working on a project where we are trying to link up the carbon from compost and the farmers working in the field. So these are something. These are some systems where unless you understand a problem, you cannot then say which solution should be deployed. So I would strongly advise you, don't become a salesman of a solution or a salesman of a technology. You are engineers. Engineers are supposed to find solutions. You are not salesmen. You can't sell a water saving device or a eco-friendly treatment plant. This is not the way. You are not salesmen of that. You have to find the problem and then see what solutions which are currently available can fit, or if there is no solution, find a solution. That's the way to go ahead. Any other question? Somebody, Srinidhi, speak about thinking out of the box. So thinking out of the box is, like I told you, so we have the cardinal definition in environment is the polluter should pay. So polluter should pay, but in a solid waste management, you are charged 30 rupees per house. Now, whether you produce no waste or you produce a waste, you produce 10 kg or produce 100 kg or 1000 kg, you are still charged 30 rupees. That does not make sense. So you need to think of something which will sort of bring into account or bring accountability to people who generate waste. That is one. Second thing, you should not find a solution which will change the habit. So there is a solution where they got QR code in the house. So the waste picker comes, scans it using a mobile, which is a technology again, and then it will give the name and address of the house. Then uses a digital weighing machine to weigh the packet of waste which comes from the house. So you're also accounting the waste and you're writing down in a book and then going back, typing into an Excel sheet and creating a database, and then you're doing an analytics. Perfect. But then where you used to collect 150 houses in a go, that collector can only do 40 houses because of this transition from the regular way of working. So you pick the waste, you weigh the waste, you write it, and then there's an error in recording and an error in again retyping into an Excel. So many things which are happening, and then you will get to know at the end of the day only. Whereas the Sevak which we did, moment you deposit the waste in the vehicle, the vehicle itself acts like a weighing scale. So you get it. And you can also select which type of waste is being put. So you also can do the segregation accounting. And then you can also do a double accounting, because when it goes to the processing plant, you can then say the sum total of it should be same. So in case somebody is taking away material, you can find out there is the vehicle had 300 kgs, when it reach the plant it has only 200 kgs. That means 100 kg has gone somewhere, where it should be on the road, or it should be a valuable material which is taken away by somebody. Anyway, it's recycled, that's a different part. But the process plant which works primarily on the quantum of waste will not be able to work viably. So that's something which we can do. Same way, if you're picking up construction waste from a corner, you can find out what waste came in, at which place. You can put a remote camera at that place, or you can put an inspector at that place instead of simply monitoring everything. So you can spotlight the problem area with this particular equipment. So that's one. So you can think of out of the box in many cases. Finally, it is like this. If somebody has a problem, we are willing to look at it as a challenge and then find a solution to it. There are a lot of investment in India where, okay, for example, Indore is running consecutively 4th time in the country. It has been winning the Swachh Bharat Abhiyan. Every city tries to emulate and copy it. Very good. But is the technology adopted in Bangalore? Can the Indore project be replicated? Can it be just cut and paste solution, or should it be adopted or adapted? So this is something, because waste characteristics is different. A waste in Mangalore is different from waste in Bangalore, and it's different from the waste in Rajasthan. So unless you respect the waste and the site context and the specificity of the waste, you cannot have a solution which works. So to customize it, you need the data, and the data, you will have to find out what data sort of affects this, and then find solutions to that. So basically, you have a problem, you do a fishbone or Ishikawa or the cause and effect diagram, find out what thought processes or what aspects can impact the result, and then start finding solution for it. So I strongly encourage the engineers to look at it from a cause and effect type of issue. We did an interesting project in Nasik, where they were getting about 400 tons of solid waste and generating around 20 tons of compost. Very good compost. Compost used to get sold out the moment it was produced. Everything was going on smooth. But as a practicing professional, we know that that quantum of compost generation is very low. That means the efficiency is low. So we monitored it. See, we don't have digital access, so we were monitoring in the conventional way. We monitored the input green waste, output compost, and they realized that the efficiency is not what we want. So we then started what we call failure analysis. Why is the plant not performing that? And then got data, converted that, and then from a 20-ton per day plant, it is now, when we left after 1 year, it was almost 80 to 100 tons. Output, compost output. And when we started, the compost had a lot of heavy metal ingredients in it. When we did the analysis, by the time we came out, 80 tons and it is one of the first cities to get a Harit certified compost. In fact, that plant is now handled beautifully by a private sector operator, and that also won the Swachh Bharat award, the compost plant. So this is how you do. And another project which I would like to say is Tirupati, where the collection transport was not very organized. They had a lot of dumper bins, that is skips, which are placed inside the city, and everything was overflowing. The drains were black, is what they used to say, black, pigs running all over the place, and diseases and other issues. They had about 1,000 staff, the municipality staff, and they have outsourced the work to 1,200 contractor staff, about 2,200 doing the collection transport. Now, when we stepped in, we wanted to improve the solid waste situation. We were given a clear mandate. We cannot increase the cost. See, obvious thing is, when we do a solid waste management, if your collection is not good, we want more people, we want more vehicles, we want more dustbins and infrastructure. That's very clear. Everybody knows it. So we were given a mandate saying that no cost budget, no increase in budget. You cannot recruit people, you cannot contract new people, you cannot ask for new vehicles, you can't ask for anything. So it is like that. And then we started with the fundamental belief that they are already overstaffed. That was the fundamental belief. And we worked towards it, where 1/3 of Tirupati, we made do away with all the bins With just 2 tractors, we could collect the waste, and we released 500 people back to other 2 wards because we could work with that. So this is something I want to bring in. It's a way how you look at it, how you look at the problems. So if you think the usual problem is, okay, less funds, we are spending less money, hence it's not good. So more funds, that's not sustainable. That's not economically viable also. So we have to start from the fundamental principles and say, okay, does it make sense? So then you will, if you do a cause and effect, you will really understand what should be impacted so that you get a better result. So one more question, do you think electric vehicle is the future of the smart cities? Again, I would not call electric vehicle the future. Cycle could be the future of the smart cities. Electric vehicle, you are only solving one part of the problem. The problem is air pollution. Now, where do you get electricity for this electric vehicle? You're looking at solar plants. Well, solar plants also needs land. If you're looking at the Raichur and the other thermal projects and the nuclear projects generating electricity, all of you know that when you generate electricity at one point and transmit to another place, 50% of it goes in T&D losses, transmission distribution losses. So you generate 2 units, you get 1 unit in Bangalore, and that 1 unit is used to charge this electric vehicle. Air pollution is reduced. What about the battery problem? Battery has to be changed every 3 years, 4 years. So that's the problem which nobody is foreseeing it. You need a battery, and making lithium battery or making whatever battery, all these are rare earth. We don't have access to rare earth in India. We have very less. The only other country which has one of the best resources is China, and with the type of situation, political and economical situation, that would be the weapon of the future. Rare earth itself would be the weapon. So if you don't give rare earth to a particular country, that country's dreams are gone. So what do you do with all the electric vehicles later on? You don't have a battery, for example. So these are some things which you have to think. So a solution is not something which is straight away apparent to you. You have to look at it from the fundamental. That's the most important aspect. Fundamental is the most important thing. Don't think you have so don't become a salesman of an electric vehicle. The simplest one is the Gandhian way of living, where you produce for your community, live and let live. Then you don't need anything called smart. That's what I told you about the last slide. Don't think of technology, don't look at engineering as a solution for everything. Nature knows best. See if you can simulate nature. Anything else? So one more question. As I observed, there's no waste management happening in rural areas, and very few people or no one talks about it. Why is it, sir? I think this is a way of looking at it. We are looking at it with tinted glasses. So why is this no waste management happening in rural areas? I don't think so. I don't agree with that also. Because do you see heaps of, if you walk in Bangalore, you see waste everywhere, in the drain, on the road, on the footpath. Do you see such context in villages? No. The green waste which you produce is already becoming compost. It's already being fed to animals, your cows, your other pets. No, the hens and chickens and all the ducks. So these are the things which are eating it away. So dry waste, yes, dry waste is a problem because that is bought out by these urban guys. Can we find some other way to sort out the dry waste? Well, then I think village is the place to learn. Because like I told you, we are trying to move the compost from city to the village. They have a shortage of compost. So I don't think that is a situation. And in summer, we are still facing electricity problem. In this case, so that's what. See, you are creating a need for electricity and then trying to find a solution for electricity. That's not the way. See, when we put megawatts of solar power plant, it needs land. If you go towards the Pavagada and Tumkur and Rajasthan and wherever you see solar place, under the panel, can we grow anything? Nothing can be grown. That's a valuable land which is going off. Agricultural land which is getting wasted. You are trying to get one problem sorted out, electricity. But what are you talking about? Food, agriculture. What about the biodiversity which lives in the earth? You are not looking at that. That is a major issue. And then the solar panel also needs maintenance. You need water to wash the panels. Otherwise, the panels will go for a toss. So what do you do about that? Where do you get that water from? So all these things have to be thought in holistic manner. There's no right or wrong. I don't say solar is wrong. I don't say solar is right. We as civil engineers, being the sort of, I call it the mother engineering, we have to look at it more from a holistic point because we impact most of the sectors. When we have a need, the electrical engineers can come in, the solar engineers can come in and fit it. But that is a different aspect of it. But if we can somehow eliminate the need for these solutions, then that is the best planning we can do. So when it came to thermal plants, you know, the fly ash was a major issue. Somebody found a solution for the fly ash and made bricks and cements out of it. No, you created a problem and then you're finding a solution to, and then you now need houses to use the cement and you now need houses to use the blocks. That's not the way. You have to find what is more sustainable. Any other questions?
Are there any other further questions? Any other queries? Pravinjith sir, thanks a lot. Thanks a lot, Rajesh here. It was really an excellent presentation and excellent start for our faculty development program. I strongly believe that my colleagues here, fellow participants, and I also see some students, I'm sure that, you know, everyone has benefited and, you know, they will consider you as an example and role model for the achievements that you have. And if you know, there are no further questions, then I would request my colleague, Dr. Anup Ekbote, the coordinator of this event, to please extend the vote of thanks. And my dear friends, before I conclude and before Anup takes over the proceeding, I would like to remind you that the afternoon session will commence from 2 p.m. All the participants are requested to log in the same Google Meet by 1:50 p.m. Thanking you. Anup, please take over. And Pravinjith, sir, excellent presentation. It's really nice.
Thank you, Rajesh. So the students can contact me. I think you have my contacts. So I would strongly discourage you to think as a civil engineer, think as more as a solution provider and an ambassador of ensuring sustainability in the world. You know? So that's how we should look at it, and that's what we have to remind ourselves continuously.
Thank you, sir. Thank you. Thank you. I would say that presentation was very informative.